Welcome back, wonderful Python family. Well, if you have ever wondered, how can I work with databases using Python, not inside a framework like Django or Flask, you have come to the right place. In this class, we will look at how we can use SQLite, the database that ships with Python. We'll cover why use a database to begin with. Then we'll create database tables and data. We will insert, update, delete, drop, and retrieve data. We'll do an in-depth look at the select command. We will alter our database table. We will implement check constraints. We will look at the SQLite command interface utility. We'll look at group bys, joins, and unions. And finally, we will do a bulk upload from a CSV file into our database, and then we will export data into a CSV file from our database. We have so much to cover, I can hardly wait to go through it. Why do you even care about using a database with Python? Since I know I can store data for later use in a CSV file or a text file, why even consider a database? Well, as the data set you're working with gets larger, you will start to consider the best way to search for your data, structure your data, and how changes to the data will impact your computer program. A database provides the means to organize your data and a defined way to access it. You might be wondering what database we're going to use during this course. We're going to use SQLite, as SQLite ships with Python, so there's nothing special to install. We will simply need to import it into the script we create. SQLite, if you don't know about it, is known as a lightweight disk-based database that doesn't require a separate server process. So it's easy to get up and running, and you're going to see in just a second how easy it is. In here, we'll create our first database. So we start at the upper left-hand corner. We create a database using SQLite. The first thing we have to do is to import SQLite with the import statement. So simply import SQLite 3. Then we create our database using the connection method. So we've chosen the variable conn, C-O-N-N, equals SQLite.connect, and we pass it the name we choose for our database. And I've chosen first_db.db. Once we execute this code, our .db file gets executed in the directory that we're sitting at presently. So you see here on the right-hand side, first_db.db has been created. Now, if we try to execute this statement again, it will make the connection to the database, but it won't create a new database. Here, we see a cursor function. This allows us to execute commands against our database. So it's our portal in to communicating with our database. Then here, we use our cursor variable with the execute method to create our first table. The syntax is create table, we choose people, and then the fields or the columns we like to create. Fname as text, L should have been name, but nam as text, a profession as text, and the age as an integer. We have triple quotes on the outside of this. That creates our table. Then here we use the variable conn, our database connect variable, with the commit method to save our changes. Nothing gets saved until we execute the commit method. Then we use conn again to close our database, and we're done. Ta-da! You have created your first database. All right, so now we'll insert records into our database in two different ways. Up at the top, I'm going to insert one record. Make note that I have commented out the table creation code, otherwise Python will throw me an error. So here you see c.execute, and C is from the page before. It's our cursor to do anything we want to do against our database. We use that C variable. So C with execute, c.execute, using the SQLite insert into people, that's the name of our table, the values, Mary, Lou, teacher, and 37, and they correspond, as you can see right above, to first name, last name, profession, and age. Okay, so it's a one-for-one relationship there. I save changes, I close the database, and the data is safely stored in our database. Then, if I wanted to insert multiple records, we'll do many_people as a variable. I have a list of tuples that, again, correspond to those 4 fields through each tuple. And then I do an execute many using C. So insert into people, again, our table, the values, question mark, question mark, question mark, question mark, as placeholders for each of the 4 values, and then comma, many people I'm taking in my list. Again, commit, close, you're done. That easy. Okay, so we've created our database, we've created our table, we've inserted records into our table. Now, how do we get it out? How do we see it? So enter the wonderful world of the select statement. Using a for loop and ordering by a field, we have our very first select. For row, and this is partial code, right guys? Because we don't see the C that came before it, but you know that C represents our cursor. So for row in C.execute, right? You see the pattern, we're always using the C.execute many, whatever the case may be. Select star from people and order by last name. So I want to select all the records from my people table and I want to order by last name. Then I print row and you see what I get. That's all my data sorted by the last name of the individual. The next thing I do is for row in C execute select star from people, same thing, but now I want to order by their age. So you see it's a slightly different output from youngest to oldest. I don't really need to commit and close. That's just at the bottom of my script here. So that's something I don't need to do when I'm just selecting or retrieving or extracting records. Now I can use the fetch one method to return one record at a time. So again, C.execute select star from people. Fetch equals C.fetch1, fetch 2, C.fetch1, fetch 3, C.fetch1, and then I can print each of those, a very inefficient way to extract the data if you wanted to extract all of it, but if you wanted to extract one record, certainly a good thing to do. We're going to dive much deeper into the select statement later in this course. And here, we will talk about updating records in our database table. One of the people in our people's table is the internationally known tattoo artist Brinks Decker. However, Brinks has just informed us that he now goes by the first name Bubba. So we need a way to change his first name in our database. So how do we do this? So this code, the beginning and the end, is the same as we have seen in the last several slides. However, we have an update statement here. Update people. So again, the table that we want to update. Set F name to Bubba, where the last name is Decker. So very simply, for row in C execute select star from people, and we see that indeed over here, Decker is now associated with Bubba as a first name instead of Brinks. So mission accomplished. So now we've built up all these records in our database table employees, and we have called to want to delete one. In fact, we want to delete record number 4 with the name Brian Criolla. So how do we do it? C.execute, using our cursor with the execute function, delete from employees where employee last name is Criolla, or emp_L name, which is the field name, equals Criolla. We execute that, and then we could test it by looking at our output data again. So for row in C.execute select star from employees table, and we see Brian Criolla is no longer in our list. So mission accomplished. Now here we're going to talk about altering our database table schema itself. Not the record stored inside the table, but the actual table itself. So I have a table called tasks, and we can see the schema below when we go to the SQLite interactive console, and we're going to learn about that in a few slides. .schema tasks, and we see that we have an ID field, a description field, a start date, and an end date. Okay? We do a .tables, we see all our tables there as well. Now 2, I now rename the task database to new tasks using our alter statement. So again, in C.execute, alter table tasks, rename to new tasks. So rename tasks to new tasks, very simply. 3, we see that TaskDB is gone now and it's replaced by new tasks when we do a .tables from SQL Interactive. Now we can add a new column to our newly created or our newly renamed new tasks database. So C.execute, alter table, new tasks, add column, effort_level, and it's of type text. So 5, we can confirm that the effort level column has been added to the new underscore tasks. Again, we do a .schema, new underscore tasks, and we see the very last field is effort_level, and it's of type text. I'd like to mention that the alter table does not permit us to delete columns in SQLite. So if we had to do that in SQLite, we'd have to probably create our table new. Now we're going to implement a check constraint. What is a check constraint and why would you want to use it? The check constraint allows for defining expressions to test values whenever they are either inserted or updated within a column. So here I have a snippet of code. Create a new table users with a check constraint on the password field. So basically, my objective here is to make sure that the password that a user uses is 8 characters or greater in length. So same as always, we import SQLite 3. We have our database equal to first_db.db. That's where we're going to insert this table or create this table. We have our connection, SQLite3.connect to our database, which is of course first_db. C equals con.cursor is our cursor, and then we use the cursor to execute our table. Now notice, create table if not exists. We haven't seen that before, but that's another way to create a table. So the name is users. User_ID is an integer in the primary key. Username is a text. It can't be null. And password text with our check constraint of length password greater or equal to 8. So we confirm the schema. Once we create that, we execute the script using the .schema users from SQL Interactive. And we see we have our check constraint on our password field. So far so good. So now I want to explicitly try to put in a password that doesn't conform to our constraint. So c.execute insert into users value 1, jsmith, and the password has hello 12. So 7 characters. So that's not 8 or greater. So we would expect that it fails. And in step 4 it does. This is the error we get. Check constraint failed, users. So for our users table. So perfect. Now I'll test the opposite. I'll say I'm going to create a password that is at least 8 characters in length, and I do that for jsmith. You see the password there, and it succeeds. I get no error, and I'm able to check at the interactive console, select star from users, and we see the record for jsmith with this password, no problem. So check constraint has worked. I wanted to give you some examples to use for the select statement. There are so many more that you could construct, but I wanted to just give you a running start of the next couple of slides on what we can do here. So let's take a look. We import SQLite 3. The import CSV is for something else that I'm going to show you later on. We don't need that for this, certainly. We have con equals SQLite3.connect, so we connect to our database, and then we create our cursor C, and we're off and running. C.execute, in our first example, select first name only. Select first name from people. So you see the output there, and these are just snippets of our database table. In the interest of space, I didn't want to give you too many of the output printouts here because I wouldn't be able to show you all the rest. So select F name from people, we see first name only, and we see 3 of our records, Carol, Barb, and Joey. Now first name and last name, select F name, comma, last name from people. For name and C, we print that out, and we see first and last name, Carol and Jones. Now we can do first name and last name, and we can order by, right? We have the order by clause by last name in descending order. We can do ascending or descending. I chose descending. So select F name, LNAM from people, order by LNAM, descending. So last name, descending order, and you see the output does just that. So higher in the alphabet to lower in the alphabet. So we see just a subsection of 2 Sally Sunshines and then Peter Park and Mildred Park. Okay, now we can do select first name and last name and age, order by last name in descending order, and then age in ascending order. Woo! So select F name, LNAM, age from people, order by LNAM descending, and age ascending. And you see the output there does exactly what we have specified. Now we could sort by column position. So this would be the 3rd column. So select F name, LNAM, age from people in order by 3, right? So that would be, in this case, that's age. And that's exactly right, in ascending order, which is default. And then we can use distinct. We could select distinct F name, L name from people. So we only want those that are distinct unto the population, so no duplicates. And you see up here in the right-hand corner, distinct Carol Jones, Barb Jones, and Joey Jones. And we'll continue with our SQL select statements here. So first we can use distinct to remove duplicates, and then we can further remove the duplicates from the subset and sort in ascending order. So I'm going to call this like a compound distinct. So first we do the distinct, select distinct F name, LNAM from people, and then select distinct LNAM from people, order by LNAM in ascending. So again, these are partial outputs. But when we do the for name and C print name, we have Barker, Decker, Dog, and Jones. So it's just a small subset of the population. Now we can use the where clause. Select FName, LNAME, age from people where the age is greater than 50. And you see here all of the people in our return subset are greater than 50. And then we can use and. Select FName, LNAME, age from people where LNAME equals Jones and FName equals Joey. So there actually are only 3 records in our database table that correspond to this. So it's Joey Jones 3 times with the ages of 31, 44, and 44 again. And then we can use a limit. Select FName, LNAME, age from people and limit it to just 2 records, and that's what we get. We can use the limit with an offset. So select FName, LNAME, age from people, limit to, and offset at 5. So we want to start at position 5 and then give me the 2. So instead of just getting the first 2 in the set, Carol and Barb Jones, now we're going to get Mildred Parks and Fido Dog. So that's how offset works. It offsets from the beginning. The next several slides will be dedicated to the SQLite commands at the command line, the SQLite command line. So just like we use Python Interactive, instead of having to spin up a script all the time to test things or to verify things, we can do the same in the land of SQL. SQLite comes with a simple command line tool named SQLite 3 that allows us for interaction with SQLite databases using SQL statements. So how do we enter it? From our command line, we can issue a SQLite 3, just like we would issue Python or Python 3, enter, and bam, we're in the SQLite command line tool. Here we do a .open first_db.db. So this will open our DB, first DB, for interaction with. If we didn't do this, we wouldn't even see it. So we'll have to do this first. Remember to issue the open for whatever DB that you'd like to query. Then if we do a .databases, we can see all the databases that we have. And right now there's just the one, first_db.db. If we want to see the tables associated, we can do a .table, and it comes back name, people, and tasks. And at the point of this writing, there were only 3. We can drop a table or delete a table, drop table, and then the name of the table, which is name in this case to be extra confusing. And then we could verify that .table, and we see people and tasks. Name is no longer there because we dropped it. So that worked. So the .schema command allows us to see the schema of the database table. So .schema tasks, and we see that we have 4 fields: ID, description, start, and end date. We can also use the .output command with a specified file, and we can gather the output and store it in a file. So .output people.txt sends it to people.txt. Now if we do a select FName from people, it no longer returns to the console. It will go to that file. It will continue to go to that file until we issue another .output, which nullifies the output command. And now if I do a .table, it's going to return back to our console. You see the output, people, and tasks. We can also issue any number of SQL commands, like this one, SQL FName from people, where LNAME is Jones, and you see the output here. If you wanted to collect that in our file, we simply go back into .output, specify the file you'd like to collect the data in, and now instead of returning to the console, it'll go to that file. Okay, and I've actually, because I like to let there be a natural sequence to these presentations, I actually have exposed you to some of the code in this particular slide. But let's go through it formally. This is another way to create a table. We import SQLite 3, as we always do. We create a variable for our database, and database, the variable, equals first_db.db. Then we have a function to create a new table. And in that function, we have con, which equals SQLite3.connect database. So it's going to connect to first_db.db. Then we create our cursor from the con. We store that in C. C equals con.cursor. And then we create our table. So C.execute create table if not exists. So we are only going to create this if Python is smart enough to see that it's not already in existence. So we call it name, and we have 4 fields. And then we have an if name equals main statement. In the body of that if name equals main, we have that new underscore table function. So that will only be executed if we run this code locally. If we import this code, this section, this new table will not be executed, because when we have the if name equals main, of course, that indicates that we're only going to be running the code that's indented underneath that statement if we use this file locally. So now we're going to take a detour into the world of joins, database joins. So we create two new tables here, one with a foreign key relationship to the other. So let's look. We're using this new way to create tables that we just showed you to create these two. So c.execute create table if not exist employees, and employee ID is an integer and primary key. Employee first name is text and it's not null, so it can't be null. Employee underscore last name equals text, and then we have a num, which is an integer, a num field, which is integer. So that's our first table. Now the one that we established the foreign key, we create tables if not exist roles. So employees, the first table, roles is table number 2. So roles.id, integer is primary key. Then we have the role, the name role, text, so the name of the role. So then we have a num integer not null, and then foreign key is num, and we reference the employee's num field. So that field name is the same, and all the rest of the field names are different for each of the tables. But that one is the same, where we have the foreign key relationship, and then we have the if name equals main to run this only locally. So let's see what we're going to do with that in the next slide. So with those two tables that we just created, we're going to use the inner join on them. So in conjunction with our select statement, we'll use the inner join. So what is the inner join? The inner join clause combines columns from correlated tables. It returns rows from the first table that has the corresponding row in the second table. So let's look at the code. For row in c.execute, select employee first name, employee last name, and role from employees. Inner join roles on roles.num equals employees.num. Now that's that foreign key. So we see the data in our two different tables. The first table here is the employees table. The second table here is the roles table. So on the right-hand side, we see the result of our join. The join matches on the num field of each table. Notice there is no employee in the facilities role in our joined output, because there is no employee in our data set in the employees table that belongs to the facilities role. So it's only bringing back things that it's able to correlate on that num field, and that num field happens to equal our role, the role for the employee. So that's how the inner join works. Now we're going to explore SQLite's group by clause. The group by clause outputs a group of rows into summary rows by values of one or more columns. So I give you two examples here. In the first one, we have a select lnam count fname from people, group it by last name. So this first select statement uses the group by clause to group records from the people table by how many last names appear. This statement uses the count aggregate function. We'll use other aggregate functions in example number 2. So records in the people table, you see them right here. If you go over to the right hand side, you'll see the output. So we have 2 Barkers, 1 Decker, 1 Dog, 5 Joneses, 1 Lavers, 2 Parks, and 2 Sunshines. And you can go and manually count those up to make sure that we're the same. So it's going to group them by last name. Okay? In the second example, we use 3 aggregate functions just to be able to show you, not that this is the smartest example, but just to be able to show you that we can use more than one aggregate function in the group by. So we use minimum, maximum, and average to group by employee last names, where the count of the num field, which is that role field, is greater than 1. So these are employees who have been in more than one role. Here in the middle, we have the records from the entire employees table. And you can see that final column num. You can see where Joe Jones, for instance, has been in row 1, 2, 3, and 5. Julia Coolio has been in row 1 and 5, that type of thing. So now, that being our group by, we can see our output here. It only gives us those people who've been in more than one role, and those are only 4 people, and it gives us the lowest role they've been in, the highest role. Not that roles would be seen like that, and the average certainly would not need to average roll, but I wanted to be able to show you that these are the various different things that we can do. Now here we'll find out about the union operator. Union is kind of like join, but the difference here is that we can relate two or more tables. They don't have to have any kind of commonality to them. At number 1 here, we have a for loop. We're using a guitar table and an electric guitar table. So select guitar brand, guitar model from guitars, and then we want a union with a select on e-guitar brand, e-guitar model from guitars. So when we look at the output here, we see that it just combines those two tables together as if they were one. And anything that was in one and the other, based on our criteria, get pulled in. So in our second one, we can do a union all. So we select guitar brand, guitar model from guitars, union all, select e-guitar brand, e-guitar models from e-guitars. So now it just pulls in everything from both tables. So you see that the population is slightly bigger and we have duplicates. It doesn't matter. In the first one, we see that there are no duplicates. If we had two records, which we certainly do in these two different tables that are identical, for instance, both have a Taylor T5. We're going to see them twice in the union all. In the union, it just gives us the one. So it doesn't give us any duplicates. That's the difference between union and union all. And in the last two sections of this class, we're going to talk about bulk uploading from a CSV file into our database table and then exporting from our database table into a CSV file. So we'll take the bulk upload first. So here we have our script on the left-hand side. As we always do, we import the SQLite 3 module and we import CSV. And on the right-hand side here, we have the CSV file that we will upload into our database table. So number 1, some of this code is going to be very familiar to you. We create a variable my_db, which represents our database. In number 2 here, we create variable upload_file, which represents the CSV we will upload to our database. So the file's data that we will want to upload into our database. Number 3, we create variable SQL_statement, which represents the insert statement we will use in our execute many function. 4 is our context manager that we will use to read our CSV file and store in the variable upload. In 5, we create our reader object, which is what we will pass as the second argument to our execute many function. Now, I have a whole module, a whole class on CSV. So if this is in any way confusing to you or you need a bit more on this, go ahead and check that out. It will explain all about CSV reading and writing. In 6, we have a second context manager inside our first, where we'll connect to our database, passing in the variable mydb, and of course that represents our database. In 7 here, we have our cursor, which is represented by the C variable. This connects to our database. And then finally in 8, we have our execute many function, which is used here to pass the SQL statement in its first position, and the reader object, which stores the data to be uploaded in its second position. So if we execute this, our upload should be complete. In 9, we'll run our select statement to verify that our data is indeed in our people table, and it is. And here, as previously mentioned, we will output data from our database table and import it into our CSV file. So we start with our import SQLite 3 and our import CSV as we did in the previous slide. And number 1 here creates the variable CSV file, which represents the CSV file we'll create and write to. Number 2 creates the connection by which we connect to our database, first_db.db. 3 is variable C, which represents our cursor, through which we will be able to manipulate or interact with our database data. 4, we create our variable export list, which is our empty list. We will append our database data to this. It's this that we'll use as a vehicle to then import into our CSV file. 5 will create the variable headers, which is a list that includes our column headers for our CSV file. Number 6 here, This is our for loop through which we'll execute our select statement that will return all the data from our people table and then append each record to our export list. 7 inside our for loop is a context manager that we will create and then write the data in our export list to the CSV file. It first creates the writer object, then it writes our column headers, and finally our records from our export list. And you see on the right hand side, this is the CSV file that we created through executing this code. So it works like a charm. Okay, Python family, thank you for watching till the end. If this class has helped you, consider helping me to continue to bring these classes to you and others. Helping is easy. Just do the following. First, subscribe to this Yogi Coder YouTube channel. Next, like this video and leave whatever comments and questions you'd like. Finally, share this video on any and all social media channels with your friends and colleagues. And as always, this code and the presentation will be stored up on GitHub at the link provided below. Okay, folks, that's it. See you in the next one.